welcome back to example 4, where we're going to find the limit of the difference quotient when f of x equals x squared minus 3x. And the formula for the difference quotient is given up here in this box at the top of this page of your notes. The difference quotient allows us to calculate the slope of the secant line, which is nearly the same as a tangent line, but instead it goes through at least 2 points on the function. And our function is a parabola, x squared minus 3x. So you'll learn more about limits and difference quotient when you get to calculus next year. This is just a preview of one of the ways that we can apply limit. So if we take our function x squared minus 3x and we use the difference quotient formula on it, we'll have the limit as h approaches 0, and in the numerator we need to take x squared minus 3x, and everywhere we see an x we substitute the quantity x plus h. So that'll be x plus h quantity squared minus 3, and then instead of x we put the quantity x plus h. Then the difference quotient formula tells us to subtract the original function, which is an x squared minus 3x. And the denominator of the difference quotient is just h. Okay, next, we're going to simplify this to get rid of the parentheses. So we'll have the limit as h approaches 0. And in our numerator, this perfect square trinomial will be x squared plus 2xh plus h squared. Then we're going to distribute this negative 3 over the linear binomial to get negative 3x minus 3h. And we'll distribute this negative 1 over the quadratic binomial to get negative x squared plus 3x. And that is all divided by h. And we can see that the x squared term and the negative x squared terms cancel. Negative 3x and positive 3x, those terms cancel, and we'll have the limit as h approaches 0. And in the numerator, 2xh, h squared, and negative 3h all have a greatest common factor of h that I can pull to the front, leaving the quantity 2x plus h minus 3. And that's all divided by h in the denominator. And then I can see that my factors of h in the numerator and denominator will cancel. And we'll have the limit as h approaches 0 of 2x plus h minus 3. And now we can evaluate using direct substitution. And we'll, whoops. We're going to keep the x, so 2x plus, and then we substitute 0 for the h, and then our minus 3, and that simplifies to 2x minus 3. And that would be the limit of the difference quotient for the function f of x equals x squared minus 3x.